Let us now look at the equations of bisectors of angle between the two lines. So you have two lines, this is your line L1 and this is your line L2, two blue lines, right? The equation of the line L1 is a1x plus b1y plus c1 equal to 0, y equal to 0, and the equation of L2 is a2x plus b2y plus c2 is equal to 0. I need these pink lines which are bisecting the angle between the two. So as you can see, this angle is theta between this line and this line, right? This line and this line, the angle is theta, and this particular pink line is bisecting it into theta by 2 and theta by 2. Likewise, you will have a pi minus theta here, and this will be pi minus theta by 2, pi minus theta by 2, right? So these, you'll have a pair of angular bisectors. So let's see how we can find the equation to that. So take a general point on the angular bisector, let its coordinates be x and y. Now, if it is an angular bisector, it has to be equidistant from both the lines. That is the condition. Why should it be equidistant? So because these two triangles are congruent. So which two triangles are congruent? Let's see. This side is common to both this triangle and this triangle, right? Imagine this triangle, this and this. So this side is common to both these triangles. These angles are equal, right? These angles are equal, and you have a 90 degree, right? So these two triangles are similar, congruent, whatever. So these two lines, these two sides also have to be equal. That means this point has to be equidistant from both the lines. So the condition that my point has to obey is it has to be equidistant from both the lines. Every point that obeys this condition lies on the angular bisector. So the condition is let me take the distance from the first line, that's a1x plus b1y plus c1 by root is a1 square plus b1 square. Don't forget the mod. And the second line, the distance is the point xy is at a distance of a2x plus b2y plus c2 by under root a square a2 square plus b2 square, right? When I open up the mod, I'll have a plus or minus, because it doesn't matter if I open up the mod, I have to include a plus or minus, because both of them could have been negative or positive, still their mods could have obeyed the relation. So why do we have a plus or minus? So we have a plus or minus because we have two lines, right? So if I take a plus, maybe I'm taking this line, then taking a minus would mean taking this particular pink line. So because there are two pink lines, there is a plus and a minus. Now the thing is, whenever two lines intersect, there is an acute angle that's created and there is an obtuse angle that's created. So this acute angle is basically having its own bisector, and the obtuse angle is having its own bisector. This is the reason why we have two angular bisectors, right? So that's why we have a plus and minus. But how do we know whether taking a plus is acute angle or taking a minus is acute angle? For which we have this table, this shortcut to find. So what you do is take this particular quantity a1 a2 plus b1 b2. So you have two equations, right? You have two equations. So take a1 a2 plus b1 b2. If your a1 a2 plus b1 b2 is greater than 0, then taking a minus sign here would mean you're taking the acute angle bisector, and taking a plus sign would mean you're taking the obtuse angle bisector, right? And if this a1 a2 plus b1 b2 is less than 0, right, then taking a plus sign would mean that you're taking the acute angle and bisector, and taking a minus sign would mean you're taking the obtuse angle bisector. So this is a result. Once again, we're not deriving as to how this result has come. It has a linear derivation, but all that you need to know is remember this result, because a lot of times this result directly is useful. So with this, we complete the topic equations of bisectors and the angle between the lines. Let's move on to the next subtopic.